introduction to exercise 8.2 on differentiating circular functions. Again, I'm going to touch on kinematics as well in a moment. A couple of formulas that we need to know, and those ones are right here. The differentiation of sine, cosine, and tangent. Sine and cosine, of course, have a very intimate relationship. X and Y values are very close together, and the formulas for differentiation are very simple. If I have sine, right, sine of kx, where k is just a constant, and then we just have the derivative being k times cosine of k theta. Right, think of it like your sine and cosine beneath. When you differentiate, you go down the list. Yeah, and that just like in chain rule, as you differentiate the inside, you bring that constant to the front. Yeah, if you have the differentiation of cosine k theta, similar idea. It's k times sine k theta, except you have a negative. Right? Unfortunately, this is just something you're gonna have to remember. Any questions so far? Okay. When you're differentiating tan, it is a little bit different. Tan k theta, you end up with, again, we're still applying the same chain rule idea where you have to bring the k to the front as a constant, but you multiply by secant squared. Secant is just, there we go, a fancy name for 1 over cosine theta anyway. Okay, so just make sure you know that. Alright, it is very likely, or very possible I should say, that the first question or first two questions of the exam on exam 1 are just differentiate this, and it could be a circular function, so it's very important that we know these formulas. But let's put this into practice. It is very straightforward once you know how to use the formula. Find the derivative with respect to theta of each of the following. I'm not going to go through all of them as I mentioned, but for sine 2 theta, we're assuming 2 is our constant, or k in this case. So the derivative, right, and I'm just going to draw an arrow. In your actual assessments, please don't write equals to cosine. There we go, equals 2 cosine 2 theta. Because if you write that, I'm going to assume you mean that equals to that, which is wrong. Okay? You're welcome to write an arrow or something just to show it means you're moving towards this. That's fine. Don't write equals. In normal circumstances, I'll give you, for example, y equals to sine 2 theta. You'd write dy dx. Or you'd write f dash of x if I give you f of x. Right? Just keep consistent with your notation. But yes, so I bring the constant to the front, you multiply it out, and then you turn your sine into your cosine and keep whatever's on the inside, kind of like your chain rule. I'm actually gonna, let's do B. Right, so tan 3 theta, same idea. I'm going to use my formula that becomes 3 times by secant squared of 3 theta. Right, this is not an immediate step that needs to be done, but this next step is maybe if you want to use it for a later step. Of course, that would equal to, and I'm going to say that secant squared is 1 over cosine squared, isn't it? And 1 squared is just 1. So it'd be the same as saying 3 times 1 over cosine squared 3 theta, which would be equal to 3 over cosine squared 3 theta. You would not lose marks if you just left it as 3 secant squared 3 theta. However, for your own practice, it's really important that you know how to do this. And if you've got a later step that uses the previous question, definitely use cosine squared instead of, or 1 over cosine squared instead of secant. Any questions? Okay. Does the whole application of the formula seem pretty straightforward so far? Okay. Let's move on to question C. Sine squared of 2 theta. Again, it's this chain rule now. I'm going to take the square out. This is a personal thing. You don't have to do this. This just makes it easier for me. I'm going to say that equals to sine 2 theta all squared. Note that I am now using equals because I am literally writing that this equals that, and then I'll do my differentiation. For the sake of this, just for keeping notation's sake easy, I'm going to assume it normally gives you y equals etc. So I'm going to write dy dx equals. Now, again, it is your chain rule. So 2 times whatever's on the inside, so sine of 2 theta, and then to the power of 2 minus 1, which is 1. So I'm just going to leave that without the brackets. And then multiply by the derivative of the inside. So what's the derivative of sine 2 theta? It's going to be 2 times cosine 2 theta. I'm going to underline each section so you know where that comes from. There. Any questions about that? I'm assuming you didn't do differentiation of circular functions last year, did you? No, okay. All right, so let's simplify that. Can we simplify sine 2 theta times cosine 2 theta? Not really, just leave it as is. Yeah. So that becomes just 4 sine 2 theta times by cosine 2 theta. For those of you that might have thought you might be able to simplify, just make sure you don't get it mixed up with Pythagorean identity. Does that sound familiar from last year? Pythagorean identity. Yeah. Sine squared plus cosine squared equals to 1. Yeah. Just don't get it mixed up. That's a plus. Yeah. Okay. Let's move on to the next one. Again, another application of chain rule. Am I going too quickly? Okay, so in this case, of course, it is, again, personally, I'm going to rewrite it out, makes it a little bit easier for me. Sine of 2 theta plus 1 squared. Please do not make the mistake that unfortunately hurts my soul every time, where just because you're used to it, you write x instead of theta and never change it back. You will lose marks in the exam, you will lose marks in the assessment. Remember, the rule is if it is not technically 100% correct, you cannot get full marks for that question. If it's a 1-mark question, that means no marks at all. Okay, let's move on. dy dx equals to, I'm deriving the outside. So I'm going to say 2 times sine of 2 theta plus 1. Again, because it's to the power of 2, bring it down to 1. I don't have to worry about writing to the power of 1. I'm going to multiply it, since it's all multiplication, don't need brackets yet. Multiply it by the derivative of the inside, so that sine becomes cosine. But remember, because of my constant in front of my theta, I bring the 2 out as well, and becomes cosine 2 theta plus 1. Simplifying that, of course, we end up with 4 sine of 2 theta plus 1, cosine of 2 theta plus 1, and that is it. Okay. All good? Any questions? No? Okay. What I get you to do at some stage, it doesn't have to be now, it's fine, is fill in this table that's below, right? Just general differentiation rules, differentiation functions. What happens if you have sine of x, differentiate that, etc. What happens if you have sine of g of x? How do you differentiate that? What's a general way you can write that? So fill in that table when you have time after this. But I'm going to move on to example 13. So if you can turn the page, example 13, thank you. Push through, we've only got a couple of minutes left. I won't be talking for too much longer. In fact, I'm only going to do one example. In this example, I've been given f of x equals to x squared and g of x equals to, etc. And we're not using g of x for the example I'm doing. And h of x equals to sine 2x. In this case, I'm going to look at question f because I think it is interesting. It is the derivative of the inverse times by h of x. Right? At this stage, you should be able to find the inverse, and you should be able to tell me that x squared does not have a singular inverse function. For the argument's sake of whoever wrote this booklet didn't think this through, we're going to assume that it's a positive version. Okay, so I'm going to assume that, here we go, assume that f inverse of x, I'm going to write assume, please don't write assume in your actual assessment, equals to root x. Alright, so the differentiation of our function, where it's the inverse of x times by h of x, you could either try to find that first and then differentiate, or you can just put them together, multiply, and then differentiate. But, of course, we're looking for, and it's always a good first step, if you're given functions and you're looking for a common function, whatever it is, to substitute the original functions in first and then differentiate. So I'm going to write, we're looking for the derivative of the square root of x times by the sine of 2 theta, I think that's what it was, 2x, sorry. Looking for that. Again, just double check, right? And actually, I've just realized I've made a mistake, and I definitely did it because I want you guys to pick up on it. Made a mistake earlier. I'm going to flick back and I'm going to see if we can figure out what I did wrong. In both questions C and D, I've done something wrong. Can anyone tell me what I've done wrong? Yes?
dy d theta.
Thank you very much. It is dy d theta. If you're using a new variable, please use the specified variable. Do not use something that you're used to. So dy d theta instead of dy dx. Did you notice that before and just didn't tell me? Please put your hand and let me know next time, yeah? Thank you. All right. So in this case, of course, it is dx because it is, in fact, in terms of x. Again, for me, it makes it a little bit easier for me to just write this as the derivative of dx, x to the power of a half times sine 2x, sorry, and then go from there. So the differentiation of this, of course, we're saying that we're going to use we're using differentiation laws where we can differentiate the first one, differentiate the second one. So that becomes half of x to the power of negative a half times by, because it's product rule, I've differentiated the first part. I'm going to leave the second part. So that becomes sine of 2x. And I'm going to add the original first part and multiply by the second part, the derivative of the second part, sorry, which then becomes cosine, 2 cosine, sorry, of 2x. Was that too quick? Okay. You can see the fear in your eyeballs. Let's simplify that. Of course, the left-hand side, left term, that becomes 1 over 2 root x sine of 2x. Have I skipped a step? Are we okay with this? Looking here, thank you. Yes?
Does the sine 2x go on the top or the bottom?
See, I did that on purpose so that you'd know that's meant to be on the top. Good to know that we're paying attention. Thank you. So yes, it is meant to be on the top. And then we add the square root of 2 square root x times by cosine of 2x, which we can simplify. Of course, that becomes, if I multiply both the top and the bottom of the second term by 2 root x, that becomes sine of 2x over, let's leave that for last actually. I'm going to multiply the second term by 2 root x, which becomes plus 4x cosine of 2x all over 2 root x. Okay. Any questions about that?
Do you have to do that last step?
Great question. If the question is just find the derivative, by definition, this will suffice, right? If it says derive and fully simplify, you must get that last one. Yeah. There is a mistake that happens quite frequently in Year 12 exams where a lot of students will oversimplify where not necessary, will make mistakes in that simplification and therefore lose marks. You could be 100% correct and missimplify something and you'll lose marks for that. So please be careful. Don't do more than you need to. Okay? In this case, if it's just derive the previous one before the arrow starts, that's fine. If this is fully simplified, you must end it up there. One last note before we end it there. Just a quick note on kinematics. There is I'll write it up here as well so that you can see in the video, displacement, velocity, and your, what's the last one? Acceleration. Alright, this is just an application of calculus, and it works like this. Okay, so if you have displacement, let's say for example your car, a very basic example. If I said how far away are you, you might say 60 kilometers. Easy, that's a displacement, right? If I said velocity, it'd be almost, and I want to be very careful with the wording of this, almost the equivalent of speed. So if I said how fast you're driving, Flynn, you'd say
60 kilometers an hour.
Thank you, 60 kilometers an hour, right? 60 kilometers per hour. You're saying kilometers per hour, it's a rate, right? So when you differentiate, right, when you diff this one, you get your velocity. When you differentiate your velocity, you get your acceleration. If I say this car is amazing, it goes from 0 to 60 in 0 to 60 kilometers an hour in 3 seconds or something, right? You're saying it's kilometers per hour, for example, yeah? So that's your acceleration. Okay, the difference is there. If I give you a displacement graph, so if I give you a graph that shows you how far away a car is, right, for however long it is, the gradient at a certain point will give you this quote-unquote speed or the velocity of that car. If I give you a velocity graph, right, and you differentiate that again, it'll give you acceleration. How fast is it speeding up? Not how fast is it, but how fast is it speeding up? That's your acceleration. Of course, if you differentiate your velocity, you get acceleration. If you integrate or you anti-diff, right, then you get the opposite. You go back up. Okay? The key difference between velocity and speed, just as a quick heads up, you can have negative velocity. Yeah, just like how you can have negative displacement. In our previous methods mini exam, one of the questions was the turning point's distance from the x-axis. Yeah? If I said displacement, in that case the answer was 3.7, by the way, and it was below the x-axis. If I said displacement, you can write negative 3.7. That makes sense. But the distance can't be negative. Yeah? Imagine if I drive forward, I'm driving 3 kilometers away. If I drive in reverse, I'm still 3 kilometers away. But your displacement is negative 3 kilometers. Yeah, so distance versus displacement. If I'm driving forward 30 kilometers an hour, that is your velocity. If I'm driving backwards 30 kilometers an hour, the velocity is negative 30 kilometers an hour. But the speedometer on your car never says negative 30. Yeah, you can reverse as fast as you want. It's not going to say negative because it's only on speed. Speed is a value, a positive value, just like distance is a positive value. You can't have a negative 3 kilometer distance. Any questions? Okay.